Kia ora tātou. This is a question for Joseph on convergence. It's a nice iterative methods one. I'm going to go reasonably quickly because I've got a few others that I want to do tonight, but I want to look at the three parts of this question. So we're given a polynomial. This cubic equation has got one real root denoted by alpha. The first thing we have to do is to figure out the pair of consecutive integers between which alpha, the root, lies. So we know all kinds of stuff about that polynomial, right? We know that it'll have three roots by the fundamental theorem of algebra, and if we know that there's one real root, we know that the other two have got to be complex and one will be the conjugate of the other. But we don't need that for this question. That's just to chuck into your brains tonight as well. The bit that Joseph's asked me about is this next bit here. So how do we show that if this thing converges, then it converges to alpha? And the last bit is to use that iterative formula to figure out alpha to correct to 3dp and make sure that we show each iteration to 5dp. I'm not going to do that bit because it's just too boring. So let's start with the first bit. So what is going to help me to figure out where the root lies? Well, it's going to be the remainder theorem. We're going to look for a change of sign in that. So Joseph, I know you didn't need help with this bit, but I'm going to do this anyway. So let's start by saying let p of x equal x cubed minus, what was the next bit? X cubed minus x squared minus 6. And let's just start with x equals 1 and see what we get. Well, we get 1 minus 6, which is negative 6, which is less than 0. So I'm looking for a sign change. Next we get p of 2 is equal to 8 minus 4 minus 6, which is negative 2, which is still less than 0. But we're getting closer, and then p of 3 works out to be 27 minus 9 minus 6, which is 12, which is greater than 0. Okay, so then we're going to say, since the sign has changed, alpha, the root, lies between x equals 2 and x equals 3. So that's all good. Okay, now we have to show that if we take this formula and if it converges, then it's going to converge to the right thing, to the value of alpha up in part 1. So the formula we start with has got x to the subscript n plus 1 is equal to this, the square root of this plus this. So what does convergence mean? Well, convergence means that the gap between x n plus 1 and xn is basically equal to 0. Which means that we can replace each of those with x. We'll put in convergence. So what we're going to do now is just that. We're going to replace the subscripts with nothings. So we have x equals the square root of x plus 6 over x. Now we're going to rearrange this. Square both sides. We get x squared is equal to x plus 6 over x. We know where we're going. We're trying to get to that cubic we had at the start. So we're going to have x squared equals x squared plus 6 over x, giving us x cubed equals x squared plus 6, or x cubed minus x squared minus 6 equals 0. But we know that alpha solves this equation. So we have alpha cubed minus alpha squared minus alpha 6 equals 0 as required. Okay, so hopefully that makes sense. Can you leave me a comment if it does or doesn't? And I'm not going to do the last bit. Alright, so any last questions, as I said in the email, feel free to email them in until about 10 o'clock and I will chuck them up onto Google Classroom when I'm done. Thanks for watching.